So hey, those previous skills with sets of numbers is really important when expressing answers to inequalities. And we're going to move towards basic inequalities, compound inequalities, and inequalities with absolute value in them. So let's start with these kinds of simple inequalities. I think you know how to do these, add 2 to both sides, divide. The only tricky thing is if you divide by a negative, you must switch the sign. So see if you can do these two as review. So I hope this does function as a review for you. This is when you multiply or divide by a negative, switch the sign. That ends up being the only big part that people end up forgetting. Now notice you now have 3 ways of representing the solutions, and there they are. Notice down here we had to switch the sign when we divided. You could have added 2x to both sides, and then you would still get the same answer, the same set of numbers. Here, this is how you express them. And there are times you're going to be told to use interval notation or to use set notation. Graph notation really helps ground you and adds consistency to what your answers are. And compound inequalities are when you're dealing with 2 different statements that are kind of slammed together. You got to think of both at the same time. There's 2 different symbols. One is an intersect, it's this, and it's most exclusive. So you can only take the values that make this true and at the same time make this true. So only the points those solutions have in common. It can also be expressed like this, kind of in sandwich mode, I like to call it. And this is a union. You include both. It's the most inclusive, include both sets. So go ahead, give these a try. I consider this kind of review. Give this a try, resume the video when you're ready. And here's your solutions. Notice I always graph it because it helps me figure out what's going on here. And notice I've given graph notation, interval notation, set notation, or set builder notation. Okay, and down here the same thing. There's graph, interval, set notation. All 3 notations in the solution. Now the key component to this video is absolute value inequalities. Let's look at absolute values equalities first, and then we'll combine the inequality idea with the equality. So if you have the absolute value of x equals 3, there are 2 possibilities for x. What are they? I hope you know these to be 3 and -3. So if you have a negative on the inside, when you remove the absolute value, take the opposite of that negative to make it +3. So if you have x minus 4 equals 3, there are 2 possibilities for x minus 4. One of them is where, and I like to put a positive version, is that if x minus 4 is positive, or if x minus 4 is greater than 0. So in that case, when I take away the absolute value signs, I leave it the same. So if it's positive on the inside, then I say x minus 4 equals 3. If it's negative on the inside, then I have to take the opposite of x minus 4. And then I proceed to solve as I would normally. X equals, add 4 to both sides, 7. Negative x plus 4 equals 3. Negative x equals -1. I ran out of space. So pretend I could write it down below. X equals 1. So there are 2 possibilities. You can check them out. And both of them work. And notice that if you plug x equals 1, 1 minus, you get a -3. When you take away the absolute value, take the opposite at -3. Always consider both possibilities when you solve. Oh, it looks like I actually had more space down here. So you have to consider both possibilities, and I like doing this with arrows. With equal signs, it ends up being a little bit more straightforward. When it gets to be inequalities, it's a little bit more complex. So have these a go. Make sure you can do these. Okay, let's look at the first 2. I considered both possibilities. I got 2 answers. Always remember to go back and check your work. Same thing happened here. I get these 2 answers, plug them in, make sure they work. This one, some of you might be really savvy and say, okay, absolute value, that's always a positive number. It's never going to be equal to -18. So you can right away say, blow that sucker out of the water. That is an empty set. There are no values you could plug in for x that would make that true. None. None, because this has got to be positive. Maybe you didn't recognize it, and you might go through the process and do this. And if you check your work, you plug in a value, you'd find, oh man, that doesn't work. No, really, absolute value is a distance. Some people like to think of it as a distance between zero, but we can look at it as a distance between 2 points. Like if I'm going to find the distance between 2 and 21, you might say 21 minus 2. Well, what if you don't know which number is larger? If you took 2 minus 21, you'd get a negative number, but if you took the absolute value, you'd get the same thing. So actually, the distance between 2 points is defined as the absolute value of the difference. And then it doesn't matter what order you subtract those values. So over here, 5 minus a negative 17, absolute value is going to be the same as negative 17 minus 5, absolute value. So that distance, absolute value. So we do symbolize the distance as being a minus b equals d. So let's take a second to think of the distance between 4 and some number is 11. We don't know what that number is. So let's say we have 4 and there's some number somewhere, but we know the distance between that number and 4 is 11. So it must be 11 units away from 4. So it could be over here. And this would be one possibility for x. We can call it a if we want. And then it might be on this side. So that's where 11 could be. And it might be over here. We could call that b. And it's going to be a different number. So I could say, oh, here I've done it. Placed a 4 in the number line. I found 2 points. So you could do that by taking 4 plus 11 and then 4 minus 11. That's the same thing as 4 minus, this is your x, it's either a or b, equals 11. So 4 minus the distance between 4 and some number is 11. So let's proceed to solve this using the strategy we just did by saying, okay, if it's positive, 4 minus x equals 11, and so forth. If it's negative, we've got the opposite of 4 minus x equals 11. And proceed to solve. And here are your two values. Notice it fits up here. Here would be the 15, and there would be the negative 7. Using the same strategy, we can say, okay, the distance between 4 and that some number is greater than 11. Let's put this on a number line. So if I have 4, and then here's my some number, and there's my other some number, and we're going to call them both kind of x down here, is greater than 11. So this distance was 11, and these points inside here are less than 11. So greater than 11 is going to be, I like to call these the wings, and I've heard other people start calling them the wings too. So this is if it's greater than, we're looking at the wings. If it's less than, we're looking at the side, the pieces on the inside, but greater than, we're looking at the wings. So let's go through and analyze this. So here I go through the same process as I did before. I have to remember to switch the sign. That will inevitably always happen to you. Okay, and notice these fit that picture that we had, where here this was negative 7 and this was 15. So then I can express this. Oh my goodness, I can express this in interval notation. So when I use interval notation, I've got negative infinity, negative 7 paren, union 15, comma, infinity. I can say, okay, I'm looking at this bottom line here. It's very, very similar to set notation. X is a member of the set of real numbers such that, looks like I'm using the vertical bar a lot. And let's go left to right. I could just copy these guys over, but it helps to organize our work and make a parallel here by saying X is less than negative 7, union 15 is less than X. Notice I'm always using less than signs, and I can think possibilities for X, 7, then there's 15, and then the possibility for X. Let's look at another. Here, if it's less than 11, I've got the same picture. Here's the 4. I'm 11 units on either side. My possibilities here. And if the distance is less than 11, then I'm really looking at these values in here. We could proceed to solve this, and you'll find the absolute value signs are different. And so let's do that and see what happens, because it'll have a little different feel, but the values will be the same. Now notice we're completely consistent. But what I want to look at is that this, I have to have both of them true, that I'm looking at x is less than 15, and at the same time, it has to be greater than -7. So some of you might have memorized that this kind of situation has to be an intersect problem, and this kind of problem up here must be a union. If you think of this as distance and place it on the numbered line, and either consider it the wings or the sandwich. I like thinking of this. This is the sandwiched. This is where your x is sandwiched in between -7 and 15. And I can actually make a set builder notation out of that really quickly, or interval notation, -7 to 15. So let me actually, here's my 3 notations for the answers. It would be nice if I had included -7 and 11 here, but there you go.